The concept of an immovable Earth, positioned at the very heart of the cosmos, was underpinned by a mathematical framework created by the gifted Greek astronomer Ptolemy. To his treatise, celebrated in the medieval era as the Almagest, we attribute the cataloguing of various star patterns, such as Ursa Major, which remains in use today to map the night sky. For centuries, the Ptolemaic model remained robust and persuasive. More importantly, it served as the cohesive force behind a comprehensive worldview. It was indispensable for justifying the descent of physical objects and the motion of clouds and stars, as well as for anchoring theological doctrines regarding humanity's central location in the universe. Nevertheless, by the 1500s, fueled by evidence of our planet's diversity, from voyages of discovery and a time when the Church of Rome's dominance was beginning to waver, the flaws in Ptolemy's design became apparent. The release of Nicolaus Copernicus's De revolutionibus orbium coelestium on the revolutions of the heavenly spheres in 1543, published posthumously, ultimately signaled the twilight of Ptolemaic theory. The Earth, Copernicus observed, guiding the path of the Moon, passes along a great orbit among the other planets in an annual movement of revolution around the Sun. Even though it would take nearly another 100 years to fully refine, the Copernican revolution was underway. Nicolaus Copernicus arrived in the world on February 19, 1473, in Torun, within the Kingdom of Poland. Born to a merchant father, Nicolaus Copernicus, and a mother, Barbara Watzenrode, who hailed from a rich and powerful lineage, he enjoyed a prosperous start. Following his father's passing, when Nicholas was 10, he was brought up by his maternal uncle, a scholar and clergyman who ascended to the rank of Bishop of Ermland in 1479. This guardianship ensured Nicholas an outstanding education. In 1491, he enrolled at the prestigious University of Krakow, a hub for natural philosophy. By 1496, he had relocated to the University of Bologna to advance his knowledge of Greek, mathematics, philosophy, and astronomy. During this period, he was influenced by Domenico Maria da Novara, an astronomy professor who was an early skeptic of the Ptolemaic arrangement. Notably, on March 9, 1497, the two observed a lunar eclipse together. Copernicus later studied at the University of Padua in 1501, secured a law degree from the University of Ferrara, and eventually returned to Padua to study medicine. In 1506, fully trained as a linguist, mathematician, and doctor, Copernicus went back to Poland, where he settled permanently. He had been appointed a canon in 1497, while still studying abroad. After spending several years as his uncle's medical advisor, he took up his official role as canon at the cathedral in Frauenburg, Frombork, in the newly formed East Prussia. Although this was an ecclesiastical position, it did not require the performance of religious rites. Indeed, Copernicus appeared to lack deep religious motivation. His professional life involved working as an administrator, judge, tax collector, and physician. In his private hours, he devoted himself to astronomy, even constructing a tower in 1513, specifically for stargazing. Details regarding the origins and evolution of Copernican theory are scarce, particularly because he was hesitant to publish his findings. He distributed a manuscript outlining his cosmic theories as early as 1514, which remained unpublished until the 19th century, and finished his magnum opus by 1530. 10 years later, a disciple named George Joachim Rheticus produced a summary of the unreleased book, titled Narratio Prima. Since this summary did not provoke hostility from the Church, largely because the full implications were not yet grasped, it is likely that Copernicus abandoned his reservations. Consequently, De Revolutionibus Orbium Coelestium was printed in Nuremberg in 1543, just as he died. In De Revolutionibus, Copernicus presents significant challenges to Ptolemy's defense of a stationary Earth. Utilizing physical reasoning and a preference for harmony, Copernicus deconstructs the notion of an Earth-centered universe. He points out, for instance, that stars do not seem to maintain a constant distance from Earth. Previous efforts to rationalize such anomalies using epicycles, tiny circular orbits, were insufficient and introduced needless complexity. Lacking a comprehensive physical theory, Copernicus eventually designed a solar system that blended ancient and modern ideas. He recognized the issues surrounding acceleration and falling bodies, but lacked a solution. Since the modern concept of force did not yet exist, he maintained the model of celestial spheres rather than planets traveling freely through space. Ultimately, De Revolutionibus became accessible to European intellectuals. The initial readership was likely captivated chiefly by the mathematical framework, which highlighted the inadequacies of Ptolemaic astronomy. Religious authorities initially raised no complaints. During the Reformation, the Catholic Church had more pressing concerns. It was not until 1616, and only because of the success of Galileo, that the Church placed Copernicus's book on the prohibited list. The phrase Copernican revolution remains a valuable descriptor, despite the debates over its precise nature that have existed since Immanuel Kant coined the term 2 centuries ago. It should be interpreted as the rupture from Ptolemaic astronomy started by Copernicus, acknowledging the Polish astronomer's primacy in establishing a heliocentric model. He was not solitary in this endeavor. As astronomer J.L.E. Dreyer noted, it has long been understood that Copernicus did not produce what is nowadays understood by the Copernican system by himself. This is said not to diminish Copernicus's impact, but to clarify his actual contribution. It can easily be argued that Nicolaus Copernicus was not the equal of Ptolemy or Kepler in mathematics, although at that time he undeniably surpassed his contemporaries, observes Owen Gingerich. And yet, as a sensitive visionary who triggered a scientific revolution, he stands out as a genius of cosmology with few equals. Comparatively little is known about Copernicus the man. A biography allegedly penned by his friend Rheticus has vanished. Legend holds that Copernicus was given a copy of De Revolutionibus while on his deathbed. Having suffered a stroke that left him unable to review the text, he supposedly held the book just before dying, on May 24, 1543. What remains is his iconic image, a man of dignity and piety, with high cheekbones and an intense stare, preserved in a handful of portraits. He also translated about 85 short poems by the Byzantine poet Theophylact Simocatta from Greek into Latin. These epistles range from the moral and pastoral to the explicitly ribald. Fred Hoyle, the 20th century cosmologist, particularly valued the latter group, noting that without them, I could not hear Copernicus laughing.